Okay, decay, that means R is going to be 1 minus B, which is 0.45, giving me 0.55, and we convert that back to a percentage, moving it 2 to the right, that becomes 55%. Okay, we're at growth, so this times R is going to be B minus 1, so we're going to go 5/3 minus 1. Ooh, that's a decimal fraction, right? Turns it into a decimal. So 5/3 is like 1.67. So that's going to be 0.67 and convert it back to our to our percentage. That one will be 67%. Okay, next one is growth, right? 1.03, so our R will be 1.03 minus 1, 0.03, and when we convert it, go 2 to the right, and that gives us 3%. Okay, now that you know the basic form of growth and decay functions, we're going to actually start translating some. Yes, they're going to be given in word problems, but you have to identify 2 things. Well, technically 3 things. First, if it's growth or decay, because that tells you what formula to use. Second is your starting amount. Third is going to be your rate, your R. So let's talk about this one. Spacetown has a population of 8,300 people in 2018. Each year, the population decreases by 12%. So reading that right away, the first thing that pops up to me is this word right here, decreases. So that's going to mean we're doing decay, right? Decay means smaller, decrease means go down. So we're in a we're in a degree. Degree. We're doing decay. Sorry. Our formula then has to look like this, 1 minus R to the T. So all we need is our starting amount and our R, and we can do all our pieces. So reading through it again, it says Spacetown has a population of 8,300 people in 2018. So it's telling us what the amount was. That's got to be your A. Okay, and then it also gives this guy down here. That kind of stuck out to me too. And I went, oh, it's a percent. That has to be what R is, which we would move the decimal and make it 0.12. Okay, A is going to be the 8,300. And then it wants B. B in this case is 1 minus R, which is going to be 1 minus 0.12, which is 0.88. Okay, plugging that into a formula for our equation. Y equals beginning value 8,300 parentheses B, or 1 minus R, to the T. So regardless of whether or not we understand what that represents, in this problem we just had to pull out certain pieces and look for key things. One of them is the percent. That's always going to be your R. Then you're going to look for some key word like grows or increases, decreases, decay, depreciates. There's going to be a bunch of different words that can mean it. And then if you think of it in context, it might make sense that it would go up or down. And then it's going to give you some kind of starting value. Keep an eye out for that. And that's all you need. You need A and R, and you can fill in the whole rest of the equation. So now that we have that equation, what can we do with it? This right here represents the population after so many years. Which we're calling the variable t. So if I ask what will the population be after 10 years, that's a t. So our formula, we're going to take and replace t with a 10. and then boop, 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 calculator will give us an answer. Look like this. Y equals 8,300 times 0.88 to the 10 power. Boop, boop, boop. Calculator says, okay, so this is about 2,311.56 if I round it to there. Now that's talking about population. That's the number of people. Obviously, we can't have 0.56 of a person. So I would just round that down and say 2,311 people. Ouch, that space town's going out of existence. What's happening to all of them? Okay, this one. Let's presume the population in Los Angeles County grows, keyword, at a rate of, with initial starting, right? Starting population at 18,500,000 people. So we need to come up with an equation. Let's start with the fact that it's growth. So our equation is going to be 1 plus r this time. We need an initial amount, our A, that's the 18,500,000. Then we need an R. R is 0.65%. Remembering that we need to change that to a decimal. Now be careful with this one. Just because it's already a full and decimal, you don't move it to the right. You still move it to get from percent to decimal. You move it to the left, which actually turns it into a really small decimal, which kind of makes sense to me because it shouldn't decrease that much. Or sorry, it shouldn't grow that much. All right, let's plug it in. We've got y equals A, which is really big number, times 1 plus r, all to the t power. Or if we combine those inside pieces, 1.0065 to the t. All right, now we're asking the same question again. What will the population be after 10 years? Well, that just means t equals 10. So we would calculate it out. 18500 times 1.0065, whoops, 65, not 56, to the 10 power, because that's our t. Gave a little squeak there. Sorry about that. Okay, boop, boop, boop. Calculator said about 1.78. And again, we don't have a partial person, so we're just going to round down. 19,738,289 about people. That is a huge population. 18 million people live there. Crazy. All right, let's talk about this one. This time Fred buys a car, right? There's the price of the car. It depreciates. That is another word for decay. In fact, most cars, as soon as you buy them, it starts depreciating. The value of it starts to go down, decays. And then we've got this 15% per year. So I know it's going to be decay, which means my formula is going to look like this. 1 minus r. And I happen to know A, because it told us, it's the only dollar amount, right? So it told us that it started at 25,000. And the rate of decrease is 15% or 0.15. All right, we decided already, we already decided it was decay. Write a function, that's easy. Y equals 25,000 times 1 minus 0.15 to the t, or 25,000 times 0.85 to the t. Okay, now it asks what will the value be after 6 years? That's a time. That means t equals 6. So we're going to plug that into our formula. 25,000 times 0.85 to the t, but t is now 6. And that is 9428.74. That's approximate, right? I'd round. So the value of the car after 6 years is 9,428.74. Now, why would I leave the decimals in that time? Well, because every penny counts, right? We're talking about money. Yeah, we want to go out 2 decimal places. Okay, the last question says, when will the value of the car be 8,000? Now, that's different. Now it's giving us the value of the car that it wants to be, and that's y. So if I plug it in my formula here, it says y equals 25,000 times 0.85 to the t. And what they've given me is this value right here. So, okay, let's let y be 8,000. And now we just need to solve for t. Easy. We've been doing that, right? We learned how to solve these guys. Get rid of that 25,000 first. Right, now we are at 0.85t to the t, equals, I can reduce that to 825, 8 over 25. And then how do we get that variable out of the power? Well, all we had to do was convert. So we said, okay, turn it into a log. 0.85 goes down here. These guys swap. And that's going to equal t. It's okay to have decimals down in the base. That's what this process is all for, is for solving this type of equation. Okay, boop, boop, boop. Calculator says that is about 7.01. We're just going to call that 7. So after 7 years, the value of the car will be around 8,000. Not exactly. It's just going to be around 8,000. Not perfectly. Does that make sense? Well, up here, 6 years, my value was 9,000 something. So another year later, yeah, it makes sense that it would be 8,000 or below. So identify the pieces, which formula, plug it into the formula, and then you might have to do some calculations, use the calculator, decimals, whatever you need to.